In this lesson, you will be working with the Pythagorean theorem. The essential learning is that I can find the missing side lengths of right triangles in application problems. So you're going to want paper, something to write with, and a calculator, and this will be the last lesson involving the Pythagorean theorem. For this problem, we're going to be looking at a situation that involves our superior middle school stage in the cafetorium. So the problem says, Superintendent Starzecki was informed that all school stages must have a front that is handicap accessible. In order for the stage in the cafetorium to be handicap accessible, a ramp needs to be built to go up the stage. The ramp must be 9.5 feet out from the edge of the stage so that it is not too steep. The stage is 2.75 feet tall. How long of a piece of lumber would the carpenters need to use in order for the ramp to reach the top of the stage? So you can see our situation here is that we needed a ramp to go from this floor all the way up to the stage, and the problem said it had to be 9.5 feet out from the stage. So I know from the base of the stage out, it has to be 9.5 feet. Then we know our stage is 2.75 feet tall. And the question is, if we needed a piece of lumber or to build a ramp, how long would it have to be? Okay, so we can see that we have a right triangle formed here. The blue sides are our legs, and the yellow side is the hypotenuse, so we can use the Pythagorean theorem. If I know my legs are 9.5 and 2.75, then I can say 9.5 squared plus 2.75 squared equals c squared, my hypotenuse. If I do 9.5 squared, that's 90.25 plus 2.75 squared, that's 7.56, and that equals c squared. When I add those together, I get 97.81, which equals c squared. When I take the square root of 97.81 to get my hypotenuse, I get 9.889, so we will round that up to 9.9. So therefore, if I was going to build this ramp out of one piece of lumber, I would need a piece of lumber that would be at least 9.9 feet long. This problem says a 13-foot ladder is placed 5 feet away from a wall. The distance from the ground straight up to the top of the wall is 13 feet. Will the ladder reach the top of the wall? So we can see our diagram here. We have a 13-foot ladder. It's 5 feet out from the wall. The very top up here is 13 feet, and we want to know if it reaches all the way up to the top of the wall, which is way up here at 13 feet. So if I make a little diagram out of my drawing that's been provided, I can see that I have a right triangle here. Okay, the ladder leaning against forms a right angle at the base of the wall and the floor, and then my ladder is my hypotenuse. So I can see that one of my legs is 5 feet. We don't know the other leg. We'll call that leg B, and we know the hypotenuse is 13 feet. So if I use the Pythagorean theorem, I know my leg is 5 squared plus the other leg we don't know, so we say b squared, equals the hypotenuse, which is 13 squared. And this is going to tell us how high this leg B is right here and how high the ladder will reach. So if I evaluate 5 squared, 5 times 5 is 25, plus b squared equals 13 squared, which is 13 times 13, 169. Okay, now you need to think back what you have to do when you know a leg and the hypotenuse, and you're missing the other leg. So you need to subtract 25 from both sides. And so you're left with 169. Take away 25 is 144. And on the left-hand side of the equation, you're left with b squared. Okay, we want to know what just b is, so I take the square root of 144, and that is 12. So I know the ladder will reach 12 feet up. And when I go back to the question where it says, will the ladder reach the top of the wall? Very top up here is 13 feet. So no, the ladder will not reach the top of the wall because it only reaches 12 feet up the wall. For the next example, we're going to have to create our own diagram. So example 3 says, two joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So if we take a look at what we're working with here, we have two joggers where they start off running from somewhere. So I'll make a point and we'll say that's the starting point. And then it says they run 8 miles north. So in our diagram, if we draw a line and point it north and label that 8 miles because they ran 8 miles north. It says, and then they ran 5 miles west. So we're going to draw a line and point it west. And that distance was 5 miles. Then the question says, what is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So the shortest distance would be going from where they are at after the 5 miles back to the start diagonally. It would not be going backtracking to the starting point. That would be the long way around. So we want to know how far it is from where they're at back to the starting point there. If you see our right triangle here, you can use this to help you find the missing distance of this shortcut. So we see that we have two legs, 5 and 8, and a missing hypotenuse. So I'm going to use the Pythagorean theorem again, leg squared plus leg squared. So my legs are 8 squared plus 5 squared equals c squared. 8 squared, 8 times 8 is 64, plus 5 squared, 5 times 5 is 25, equals c squared. Add 64 and 25 and you get 89, which equals c squared. We want to know just c, so we take the square root of 89. 89 square root is 9.433, and it said to the nearest tenth, so that would be 9.4. So this shortcut distance is 9.4. So to answer the question, the joggers will need to run 9.4 miles to return to their starting point. For this problem, we're going to have to create our own diagram. So example 4 says, Tanya runs 50 yards diagonally across a rectangular field that has a length of 40 yards. What is the width of the field? So I know that it said there was a rectangular field, so I'll draw a diagram of a rectangle, and that Tanya ran 50 yards diagonally. So she ran from one corner to the opposite corner. So the diagonal distance was 50 yards. Then it said the field has a length of 40 yards. So the field is 40 yards long, top to bottom. What is the width of the field? So we want to know the width right here. So you can see we have a right triangle formed here. We have a leg A of 40 yards. Leg B, we don't know how long it is. And the hypotenuse C we see is 50 yards. So if I have my right triangle, I can use my Pythagorean theorem. I know one leg is 40, so 40 squared, plus, we don't know the other leg, so b squared equals the hypotenuse, which is 50 squared. So if I evaluate 40 squared, that is 1,600, plus b squared equals 50 squared. 50 times 50 is 2,500. Okay, then notice we have b squared on one side with 1,600, so I need to subtract 1,600 from both sides so I can solve for b. 2,500 minus 1,600 is 900, which equals b squared. And if I take the square root of 900, that gives me 30. So I can see that the width for this field, or the leg of the triangle, is 30 feet, and therefore the field is 30 yards wide. Example 5. You get home from school one day to find yourself locked out of the house. There's an open window 25 feet above the ground that you could reach with the right sized ladder. You will have to place the ladder 10 feet away from the base of the house because a shrub is growing along the house. How long of a ladder will you need? So what you should do right now is draw a diagram and find the length of the ladder that you'll need. Go ahead and push pause to solve this, and when you're ready to check your answer, push play. Okay, you can see here that our legs were 25 and 10, and so when you use that to find the hypotenuse, it's 26.9, so the ladder needs to be at least 26.9 feet long.